I use a cylinder and I put the job on the cylinder. This cylinder can move up and down. Okay? I've got the cutting tool here. There it is. This cutting tool is turning. And I put it on another cylinder, this one. This cylinder can move this way. Okay? Now, to do that job, when I press the start button, the cutting tool is moving and it's cutting the groove. Then, when it comes out this side, it's going to touch a switch, which will put power on this cylinder. This cylinder is going to move up. When it comes on the top, it touches a switch, which loses power on this cylinder. It comes back. It cuts another groove. And then, when it's back, this one loses power, it comes back, I can take the job out. Do you see the two grooves? Yeah, it's been cut. So, what does the machine look like? The machine, there's the job. We mount that job on a cylinder. So there is a cylinder. We've got here another cylinder. This cylinder has got the cutting tool. There's a cutting tool that's mounted on this cylinder. This is cylinder A. This is cylinder B. We've got the start button. Then we've got on this side switch 1. We've got on top here switch 2. And we've got at the back here switch 3. Now, what is not shown on the sketch is what will be closing those switches. What I don't show on the sketch. Okay, this thing, when it moves across, you can see it can touch that switch. But what is going to close that switch? Here on this thing, there's an arm. And when this cylinder pushes it up, that arm is going to move up as well. That will touch that one. Here, there's an arm here. When it's coming back, it's going to close that switch. Can you see that this switch will be closed before I put power on? It's normally open, but it's pushed. Okay. Now, this is not required for chapter 2, but we're going to use it in chapter 3. I'm going to write down the logic to operate this machine because I'm going to use the logic to show you the design. The logic is here. If I press the start button, what must happen? Cylinder A must get power to move across. So the start button is going to put the power on cylinder A. Okay? So if I press the start button, cylinder A will cut that groove. It will move that direction. Then, when it comes out the other side, so there it's going to cut that groove while it's moving in that way. When it comes out the other side, it's going to touch switch 1. Now, what must happen if it touches switch 1? Cylinder A must not lose power. Cylinder A must stay there. So, but switch 1 is going to put the power on cylinder B. So, that means cylinder B is going to move up. Until where? Until it touches switch 2. So now this whole job is moving up with that cutting tool staying on that side. So until it touches switch 2. What must happen if it touches switch 2? Oh, cylinder A must come back. So switch 2 will remove the power, put the power off cylinder A. So now cylinder A is coming back. Cylinder A is moving back. So while it is moving back, it's cutting that groove there. And when it comes back, it touches switch 3. And switch 3 must put the power off cylinder B. So it will touch switch 3, and then B comes back. Okay? Now, in this logic, I see the inputs, I see the outputs. Where are the inputs? Start button, switch 1, switch 2, switch 3. Where are the outputs? Cylinder A, cylinder B. Right? The design of the logic is how does the inputs control the outputs. Let me start off by looking at cylinder A. There is cylinder A, there is cylinder A. What is putting power on cylinder A? The start button puts the power on. What removes the power? Switch 2. Right? Now, the moment I see something put the power on, something remove the power, what circuit am I thinking of? A latch. So I'm going to draw a latch. There's the latch. Which one of these two switches put the power on? Top one or the bottom one?
Top.
Top one. So which one must that be? Start button. This will be switch 2. Right? Let's call this relay 1, relay 2. If it is a latch, what can you tell me? This must belong to relay 1. And that must belong to relay 2. There's a latch. Right? While relay 1 has got power, cylinder A must move. That is the control of cylinder A. I've designed it. Line 1, 2, and 3. Cylinder B. Where's cylinder B? There's cylinder B. There's cylinder B. What controls cylinder B? What puts the power on? Switch 1. What removes the power? Switch 3. So what circuit am I looking at? a latch. Relay 3, relay 4. Power on is switch 1. Power off is switch 3. This must belong to relay 3, that must belong to relay 4. While relay 3 has got power, then cylinder B must operate. This is the control of cylinder B. Line 4, 5, and 6. Again, during the test, during the exam, you get the sketch. And you get the sketch. So that you can see how the machine works. Let me repeat the operation. I press the start button. Cylinder A moves across and it cuts the top groove. Then it stays there when it touches switch 1. And behind it, the job moves up until it presses switch 2. Then, when it presses switch 2, cylinder A comes back. But remember, this is higher up now. And it cuts that bottom groove. When it comes back and it closes switch 3 again, cylinder B must lose power. Cylinder B comes down. I can take the job out. Must I show you again? Cylinder A is here with the cutting tool. Cylinder B is down here. I press the start button. Cylinder A gets power. It cuts the top groove. It comes out here, it touches switch 1. Switch 1 puts power on this cylinder, it moves up. It touches switch 2. This one loses power, it comes back. It touches switch 3. This one comes back. I take the job out, I put the new job in, press the start button. Okay. Anybody that is not seeing it yet? I press the start button, switch 1. That means when that thing comes out here, it touches switch 1. When it touches switch 1, relay 3 gets power. It latches. So even if switch 1 goes open, it will still have power. When relay 3 has got power, cylinder B moves up. When switch 3 is touched, that means when this is coming back, then relay 4 gets power. Oh, sorry, I see your problem. That goes open. It is normally closed. That goes open and relay 3 loses power and cylinder B goes back down. Thank you. Must be normally closed, otherwise the latch is drawn off. Now the questions are again, what will you observe if something goes wrong? People, I want to finish this one. You don't have a class tomorrow. Am I right? Your test is on Tuesday. Am I right? Yes. So Monday is revision period. The test on Tuesday will be what we did in chapter 1, the classifying system, and this one. That's why I want to. There's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 2 is only 20 questions here, not 74. And there are only 3 are those questions here that are a bit difficult to see. Let's start again with the top line, line 1. If I press the start button, no, don't close. I'll never ask that question because what is the answer? The job don't start. Okay. Now, what will happen if I press the start button and it stays closed? Let's see. I'm going to go through the motions of the operation and then we will see what happens. So I press the start button, it's closed. It's going to put power on, so cylinder A is going to move. It's going to touch switch 1. When it touches switch 1, that closes, relay P gets power, B goes up. Right? Now when B goes up, it's going to touch switch 2. So that goes open. You agree? If that goes open, A is coming back. And it's going to come back because this thing is pressing switch 2 all the time until it touches here. Now, the moment it touches here, what happens? B is moving down, right? So it's not touching switch 2 anymore. Do you agree? But if it's not touching switch 2 anymore, that closes. But the start button is faulty. It's closed. So what happens? When A is coming back, B is moving forward again. So what you will see is A is going to cut the first groove. B is going to move up. So it's going to cut the second groove. Right? Now, when B is coming back, the moment it cut the first groove, it moves up, B is coming back. The moment B is coming down, A goes forward again. So it cuts another groove like that. Then it will touch switch 1, B moves up. It touches switch 2, A comes back. Then when B comes back, B moves forward again. So it's going to do 2, 3, 2, 3, 2, 3 all the time. You can use a sketch to explain what happens. So this will happen if the start button stays closed. But before I leave that, can you see if you look at this drawing? If this stays closed, it's going to be the same as if the start button stays closed, isn't it? So this will also be the same problem if normally open of R1 in line 1 stay closed. I will put the difficult ones on the board here like this. This is one of the 3 difficult ones to see. That is if the start button stays closed or this contact stays closed. Then it will cut the first groove, it will cut the second groove, and then when B returns, A gets power again and cut the third groove from left bottom to top right. And it will repeat lines 2 and 3 all the time. Right, that's one difficult one out of the way. Yes.
So do you have to mention that you can't replace the cut steel because it's now continuously moving?
No, I only ask you, the question says, you're standing next to the machine. That problem happens. What do you see? You don't have to mention that you cannot take it out or whatever you. The answer to this problem is, what will you do if you see this? After this. What do you see? It cuts the top groove, it cuts the bottom groove, and then when B starts coming back, A gets power again and cuts a third groove, bottom left to top right. That's what you see. I don't ask you what you're going to do about it. What you're going to do about it is to stop the machine. Take it out, find the mistake, repair the mistake, and then put a new job in, because that one is cut. But that's not what I'm asking you. Another question? Somebody has another question? Okay. Right. We've done that open and closed. We've done this closed. What will happen if this one stay open? What is his job? To keep A moving, to cut the groove, isn't it? So if I press the start button, A starts moving. Now if I release the start button, it does not latch. So relay 1 lose power. What happens? It comes back. So cylinder A will only move while you're pressing the start button. When you release the start button, A comes back. Now people, I don't want you to become bad technicians. A bad technician will say, okay, I'm pressing the start button, it's moving, I release the start button, it's coming back. Okay, let me keep it pressing until it comes out the other side. That's what a bad technician will do, because now you're supposed to look after 3 machines, you become part of this machine. Because you're doing the job of that thing now. Okay? Next one, easy. What will happen if this stays closed? That means it's touching switch 2, but relay, that contact of relay 2 does not open. What will that mean? It means relay 1 can't lose power. Isn't it? So, what will happen is it will cut the first groove, B will move up, and then the machine will stop, because A cannot come back, because it doesn't lose power. Okay? So if that stays closed, it will cut the first groove, B will move up, and then the machine stops. That's what you see. What will happen if this open and stay open? Then relay 1 cannot get power. So it will complete the first job. Next job cannot start. Because you cannot put power on relay 1 again. It will complete the first job and the next job cannot start. That is if that stay open. What will happen if switch 2 stay open? Same as what we had before. That implies that you don't get power to open that. So it will cut the first groove, B will move up, the machine will stop. What will happen if it touches switch 2, and then when cylinder B goes back, switch 2 stay closed? If switch 2 stay closed, that means relay 2 will be open all the time, will complete the job, next job cannot start. We go to line 3. Hey, that's so easy. If it stays open, the job cannot start. If it stays closed, cylinder A will have power all the time. It will be stuck on the right-hand side. It cannot come back. We come to line 4. We enter another bit of a complicated answer. What will happen if, this is, first one is easy, what will happen if switch 1 don't close, B don't start, it stays at the bottom. Okay? What will happen if, when switch 1 closes, A goes back, but switch 1 stay closed? That's the error. If switch 1 stay closed. Now let's go through the motions. Remember, switch 1 is staying closed. Now, on the next job, I press the start button. When I press the start button, relay 1 gets power. Right? But, what happens if relay 1 gets power? It's moving away from switch 3. Isn't it? If it's moving away from switch 3, then relay 4 closes. Huh? You see that? Now, the moment A starts moving, switch 1 is closed. That is closed. Relay 3 gets power. What does that mean? Cylinder B is moving up. So, let me demonstrate that problem. When I press the start button, and this thing starts moving, then this thing is moving as well. What do you see? It will cut the first groove. Like that. And then it will come back and cut the second groove at the bottom. That will be if switch 1 stay closed. The first groove will be cut at an angle down, top left to bottom right. But can you see that we will get the same problem if this contact stay closed? We will get exactly the same problem because they are in parallel. It doesn't matter which one stay closed, we will get the same problem. So, or if the normally open of a relay 3 in line 4 stay closed. That is the other, a second funny one. Now, let's see what will happen if this contact of relay 3 stay open. Okay, what will happen then? When I press start, this thing moves up, it touches switch 1. That relay will get power, this will close. This one is moving up. It touches switch 2. So that means it's cutting the bottom groove, it comes back. The moment it starts coming back, it's not touching switch 1 anymore. Okay? And what is the problem? This is open. So both of these are open when it starts coming back. Do you see it? What happens if this is open? Relay 3 lose power, and that means cylinder B goes back. So, let me demonstrate. It's going to cut the first groove. And then, when this goes up, and then when this one is coming back, that one is coming back at the same time. And it's going to cut like this. It's going to cut the first groove correctly, and then the second groove will be cut like that. That is, if the normally open of relay 3 in line 4 stay open. That is what you will see. The rest of the questions are easy. If this contact stays closed all the time, relay 3 cannot lose power, and if relay 3 don't lose power, cylinder B will stay on top. It's going to complete the job, but B will stay on top. It's not going to come back down. If this stays open, relay B cannot get power. It will only cut the first groove, and A will stay on the right-hand side. He cannot get power. Line 5, if switch 3 doesn't close, then relay 4, that contact cannot go open, cylinder B will stay on top. If this one closes and stays closed, that means when A starts moving, this switch don't open, it stays closed, that will still be open, cylinder B cannot start. It will cut the first groove, and then it will stop, B cannot go up. Line 6A. It will stay open, cylinder B cannot start. We'll cut the first groove, and then it will stop. If this stays closed all the time, B has got power all the time, it cannot come back. It will complete both jobs, but B will stay on top, it's not going to come back. So there are 1, 2, 3, 4, 5 questions with 3 different answers, which are the complicated ones. You will get at least one of those to do, most probably 2. The others are quite easy. Just say, what's the job of this thing? It's not doing it, sorry. This will be the problem. This is what I will see. You can either use a sketch or you can write it in words. What is the words for this one? It will cut the first groove, it will cut the second groove, and then when B returns, A gets power again and cut a third groove from bottom left to top right. That one, when the moment you press the start button, B gets power and the first groove is cut at an angle from top right to bottom left. Then it will cut the bottom groove coming back normally. This one will cut the first groove. The moment B starts moving up, A is returning, and it will cut the second groove, bottom right to top right. I don't care if you give it to me in words or in a sketch. Got it? See you on Monday for a revision. Over the weekend on Saturday.